All right, David, any problem I can help you with? 39. All right. Oh, okay. So here's the, yeah. So this is, okay. All right, 39. Can you hear me through the, no? So we're okay. Okay. We'll try this. Okay, 39. So 39, you're asked to come up with an equation for the graph of this if you know that you started with y equals x cubed. So what I'm here to tell you is that there are three, count them, 1, 2, 3 different transformations that occurred to this graph. Can anybody tell me what one of them is? Up 2, because the scale is each square is 2. Okay? Yes, so Brianna is right. One of the things that happened to the graph is it got moved up 2. So to do that, you add 2 onto the end of the equation. Okay, good. What else happened? Yes, it went to the right 4. So that means I need to go x minus 4 inside the parentheses. Don't forget, things to the right and to the left. And then it's always the opposite. Okay, so to the right 4 is minus 4. All right, and then what's the last thing that happened to the graph? Yes, it did flip, because normally the y equals x cubed graph looks like this, and so it got flipped around this way. Josh pointed out yesterday that because x cubed is an odd function, in this case we could put the negative outside the parentheses or inside the parentheses. I think it's easier to just put it on the outside and write it like that. Okay, so the equation for that would be y equals negative parentheses x minus 4 cubed plus 2. Yes? Yes. I don't actually know what the directions say. Oh, yeah, it does say determine the transformations, but whatever. What? Only if your name gets called before 3 people say they don't have questions, yeah. That's why I do it. We had a staff meeting this morning, and so we talked about a lot of different things. But then one of the things we always talk about is teachers choose one student that they found particularly annoying in the last week or so, and you talk about things that we can do as a group to sort of get that teacher back. So your name came up last month, and so that's why I was doing those things. Luckily, you're off the hook today. Nobody said, let's get Emma Kaler. Nobody said that. Chris, you weren't here, right? So you don't. Yeah. Doesn't count. Emma. 36. Sure, I'd love to do number 36. So 36 is pretty much the same as the one that we just did. I believe for this one there were 3 transformations as well. Can anybody tell me what one of those would be? Down how many? 2, because this is now at negative 2. This little point in the middle of the graph should be there, but it got moved down 2. So that means I'm going to put a minus 2 at the end. How do we know which one is what? In terms of the side to side or the up or down? You mean? Which one of what's is first? It doesn't actually matter. So the first side, that's just the first answer that I got, so I'm just going to go with, yeah. This little part right there is supposed to be at the origin. Yeah, that middle part of the graph. Okay? It's kind of like a vertex, but not really. Okay, what else happened to this graph? To the right 3, which means that I need a plus 3 inside. Oh, sorry. That should be a minus 3. Okay, inside the parentheses is the opposite. Okay, so down 2, right 3, what else? Flipped over the x-axis. So there's got to be a negative in front. Okay? Emma, does that help? You weren't even paying attention. You asked your own question, and then I'm gonna bring up your name next staff meeting. You're gonna be back on it again. Brennan, questions? 27. Okay, 27 says the kinetic energy generated by a 5-pound ball is represented by the formula K equals 1/2 times 5 V squared. If the ball is thrown with a velocity of 6 feet per second, how much kinetic energy is generated? So in order to answer this question, we just have to figure out what the different pieces are here. What does the K stand for? The kinetic energy. This is what we're trying to figure out. Where does the 5 come from? The weight of the ball. And so that leaves us, the V is the, Abby? Velocity. Okay. So if the velocity is 6 feet per second, then all I have to do is plug in a 6 for the V. Okay? So 1/2 times 5 times 36 equals 90. Any physics majors in here? What the units for kinetic energy would be? What's that? Okay. I'm going to go with like pounds times feet. I don't. Yeah, kinetic energy. Energy is joules or something, right? Yeah, is that right? But then I don't know. That would be like meters and kilograms, and so I don't know. Brennan, you good there? Okay. Okay, Ashlyn. Okay, 33. So can I start with y equals x cubed and get to y equals negative 4x cubed just by doing stretches, shrinks, up, down, left, right? Yes. What did I do to get there? Not down 4, not up 4. No. Right, the negative is a reflection. I'm trying, yeah. So the negative in front of it is a reflection over the x-axis. Okay, what is the 4? Okay, good. And then the 4 is a vertical stretch. Yeah, so because it's outside the parentheses. So for it to be a horizontal stretch, it would have to be like this. Okay? Inside is always horizontal, outside is always vertical. Callista? Oh, the units don't matter for that one. We went with, yeah, 90 is fine. Yeah, yeah. Okay, so that means this is a yes. We can start with y equals x cubed and do 2 transformations on that graph and end up with y equals negative 4x cubed. Okay? All right? All right. Danica, you need anything? Nope. Okay. Oh, she's on her phone. Bad kid. Ariel, questions? You weren't here. Okay. McKenna, questions? 18? Yeah, go for it. All right, so to find the real zeros of the function, you take the function and you set it equal to 0. That's one of the reasons they're called zeros. So subtract 10. And then, awesome. Yep. And then cube root both sides. So x plus 5 equals the cube root of negative 5. And then finally, it's a cube root. Subtract 5. So my final answer is plus the cube root of negative 5. Anna, this cube root is because we were starting with x plus 5 cubed, so to get rid of that we have to cube root both sides. Okay? If it had been squared, we would have square rooted it. To the 4th, we would have 4th rooted it. To the 7th, we would have 7th rooted it. You stacking what I'm chopping? Okay. What just happened? Oh yeah, you can 50th root things if you want. Peyton? No. To distribute, you would need to FOIL this all out first, because you have to do order of operations, and it wants exponents in parentheses first. Okay? 50? 50? Did I assign number 50? I don't remember. 15. Yeah, Anna, go ahead. All right, Peyton, what do I do first? Done. Now what? Okay. Now what? Okay, so I need to divide by negative 3. Class, what is something that I could multiply by that would be the same as dividing by negative 3? Times 3 and dividing by 3 are not the same. What is the same as dividing by negative? Right, you can multiply by negative 1/3. Okay? Because negative 1/3 times negative 3, those are reciprocals of each other, so they'll cancel. So that leaves me with x plus 4/5 cubed equals, if I multiply these together, I get 8/27. Now I'm sure that as soon as you saw that, you were like, oh my gosh, this is totally awesome. Because what's my next step? To cube root both sides. But what's the cube root of 8? 2. And what's the cube root of 27? 3. So this works out to be an actual answer, not some crazy weird cube root thing. What's my last step? Subtract 4/5. To do that, common denominator is 15. So 15, 10, 12, and 15. So it's negative 2, bless you, 15. Okay? So that one came out to be an actual nice answer. No, you're not. No, you won't. No. You see how my desk is nice and clean and organized right now? When you sit over there, you like would draw on my desk and stuff and leave your garbage on my desk. And then you had that water bottle that would sweat, so there'd be a big like wet glob on my... No, you're done. No, ma'am. Luke, questions? Almost all of them. 15, 18, 27, 33, 36, and 30. What, 12? All the way back to the beginning? Oh, not quite. Okay, so we're starting with x cubed. We want to stretch by 5/3. How do I do that? Anyone? Stretch of 5/3? Multiply by 5/3. Okay? A reflection across the x-axis means the 5/3 has to be negative. Okay? If I'm going to go 4 units down, then I have to, if I'm going to go 4 units down, then I have to subtract 4 from the end. And then good to go 3 to the right, I go minus 3 inside the parentheses. Okay? You have to go. You ready? Okay, will you guys pass your assignments forward, please? All right, so going way back to the beginning of the chapter, one of the first things that we did is we classified polynomials based on the highest degree that the polynomial had, how many terms the polynomial has, and then we also talked about the end behavior. So Josh, what we're doing in this case is to write it in standard form. We write it with the biggest exponent first, and then the smaller and smaller and smaller. So how would I do that with this? Okay. No, but I appreciate you helping Josh out because he was gone for this. So, yeah, so she was just helping him out. Okay. So, yes, does that make sense how she did that? She put the, okay, good deal. All right, and then Josh, what's the highest exponent there? 4. So remember, 4 was quartic, and then, yep, and then since there's 2 terms, it's a quartic binomial. You are because you're going to copy someone's notes, and so then you'll have it. It'll be really easy to look at. And then the lead coefficient is negative, and the exponent is even. So that means the end behavior is you guys have a table that relates those things. Up, 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 down, down, up, down, down. What? Down and down. All right, so Josh, before Friday, make sure that you get those notes from somebody. Okay? Emma is a good candidate. She takes good notes. Okay? All right, let's try another one. Andrea, first, can you write it in standard form so the exponents are in order, in descending order? Okay, good. So she just had to flip around the negative x and the positive 7 so that the exponents are all in descending order. Andrea, what's the highest exponent? 2, which makes it a quadratic. Yep, and then the fact that there's 3 terms means it's a quadratic trinomial. And then Andrea, this one is positive and even, so that means the end behavior will be up, up. Yeah. Okay, questions about that? Nope. All right, how about the next one? Whoops, she just left us. Okay, Sage. Can you start by writing that in standard form? Highest exponent first and then descending order after that. Okay. Okay, awesome. Love that. What kind of a polynomial is that? Emma's got you. 4th degree is quartic. And we'll just go with polynomial. Yep. you could say quartic polynomial of 5 terms, but probably quartic polynomial is fine. And then since it's negative and even, that means the end behavior is, bless you, down, down, gesundheit. What? Wow, bless you, lots of sneezes going on. Yeah, Josh, you could benefit from this also because it is in the book if you don't want to ask Emma for her notes. Sometimes she's a little bit mean. I saw her walk down the hall and kick 2 students in the back one time. Probably should have written her up for that. Page 281. 281, yeah. Okay, Amy, will you take that one and write it in standard form first? Okay, so standard form for that one, the x cubed comes first, then 2x squared, then minus 4x, and then plus 8. So what kind of polynomial is that? Okay, good. This is a cubic polynomial. What's that? The this assignment. I thought you meant the table with the stuff. I apologize. No, you're right. This assignment is on, if you want to follow along in your book, this assignment is on page 348. Sorry. Josh? If we get to be more than 3 terms, we just use the word polynomial. So 1 term is a monomial, 2 is a binomial, 3 is a trinomial, and then after that we just go polynomial, okay? Amy, what's the end behavior? Down, up, okay. Okay, Callista, last one. Uh-huh. Good. Okay, so x to the 4th minus 3x cubed plus 3x squared plus 10. What kind of a polynomial is that? Good. And that has 4 terms, so we're just going to go quartic polynomial. And what would the end behavior be? The highest exponent is even, and this is positive, so it's up, up. Yep. All right. So the next one, this is a weird one. I'll just throw this out to the group in general. If the volume of a cube can be represented by a polynomial of degree 9, what is the degree of the polynomial that represents each side length? So what they're saying is if you have a volume polynomial, and since it's a cube, it's going to have 3 pieces, length times width times height. And altogether that polynomial has a degree 9. What's the degree of each of the pieces? 3. Good. How'd you get that? Good. 3 plus 3 plus 3 is 9. So the answer is 3. Okay? And they all have to be the same degree because it's a cube. So they all have the same all dimensions. Okay? So no, that's a weird question. Okay? All right, number 11, we're also not going to mess with. Go. Okay, so let's get to this stuff here. So we also took zeros and rewrote them as polynomial in factored form. This is such easy money. Veli, if my zeros are -1, -1, and 6, what is my polynomial? If -1 is a 0, then that means that one of these is going to be x plus 1. Because if I plug -1 into here, then that gives me 0. Okay? So what's another one? Good, x minus 6. And the fact that this shows up twice means that the x plus 1 needs to be squared. Yep. Okay? Only if this comes up twice. If it comes up 3 times, it'll be cubed. It'll be 3. Oh, no, 13 is going to have 3 parentheses. So, yeah. Okay, Jessica, can you do the same thing with number 13? Uh-huh. X, what? X minus 2, okay. And then what do I do with the 0? Yep, something. Just a plain old x, yeah. Okay. You could put x minus 0, and you wouldn't be wrong, but it's just kind of a weird way to write that. You don't really need the minus 0. Usually, yeah, usually. It can go at the end. Yep, multiplication. It doesn't matter what order you do it in. So you could put it in the in the middle if you want to be crazy. Okay, Sophie, 1, 2, 3. There you go. X minus 1, x minus 2, and x minus 3. All right, and then Anna, last one of these. I've got negative 2, 1, and 4. So my factored form is going to be, okay. All right, you guys really got to get that. That is easy points on the test. So simple. Okay, your whole test, 50 problems. No, it is not 50 problems. Okay. I don't actually, no. All right, Alexandria. Now we're going backwards. We have it in factored form, and you have to tell me what the zeros are. So the other ones, we were told what the zeros were, and then you figured it out in factored form. Now we know what the factored form is, so you tell me what the zeros are. Okay, negative 2, negative 2, negative 2, because it's cubed, right? So I'm just going to write negative 2, and then I'm going to say multiplicity 3. No, what makes that be 0? 3 times what is 0? 0. Okay, so my zeros there are x equals negative 2, which comes up 3 times, so that's multiplicity of 3, and then also plain old x equals 0. Okay? Yes. All right, I was hoping to get someone smart, and I did. Gavin. This one we have to factor. Okay? So if I have x to the 4th minus 8x squared plus 16, first thing I'm going to do is just factor it into 2 parentheses. So what 2 things go in the front of the parentheses, Gavin, to give me x to the 4th? Good. X squared and x squared. And then I need 2 numbers that multiply together to be 16 and add to be negative 8. Good. Negative 4 and negative 4. Okay. But wait. Bless you. There's more. I can now take the x squared minus 4s and factor those into not x minus 4. I need 2 numbers that multiply together to be negative 4 and add. Okay. It's going to be x minus 2, x plus 2, and then x minus 2, x plus 2. X squared minus 4 is the factor pattern that we know as the difference of 2 squares. So it always factors into plus or minus those things, okay? So now that we have it factored, what are my 2 answers? Good. 2 and negative 2, and these both have a multiplicity of 2 because they come up twice. Okay? Yeah. Yes. X minus 2 squared, x plus 2 squared. Casa, you betcha. Okay, Zoe. Number 18. What can I factor out of 4x cubed minus 2x squared minus 2x? Good. 2 goes into all of those evenly. and then they all have an x, okay? So if I factor 2x out of here, 2x times what is 4x cubed? Zoe. Got a lot of Zoes in the room today. 2x what?
Hey, shut up.
Squared. Because 2x times 2x squared is 4x cubed, okay? Minus 2x times what is 2x squared? 2x times what is 2x squared? What? Itself? X. 2x times x is 2x squared, right? And then the last one is going to be 1. Okay? Good job, Zoe. A lot of love in the ballpark today. All right, now we got to factor 2x squared minus x minus 1. What two things go in the front here to multiply together to be 2x squared? I'm ignoring them. You can ignore them. Just tell me what goes here and here. X and what? X and what? X times what is 2x squared? 2x, okay? Good. And then I know that these two numbers are going to multiply together to be things that multiply together to be 1. 1 and 1, okay? So to get a negative x, I'm going to make this one be negative and that one be positive, okay? Thank you. All right, so now I have it factored. What are the three answers, anyone? 0 for this, 1 for this. What about for this one? Negative 1/2. Good, that's the tough one to get. Because if I take 2x plus 1 and I set it equal to 0 and solve, I subtract 1 and then divide by 2. Yeah. Okay, Brianna, number 19 is an easy one. It's already factored for us. What are the two answers? Perfect. Okay. Questions about that? Any of those four? Okay. You having sage rage? Okay, not doing those. All right, so now let's do some more factoring. You're about to get one. Yeah, you're going to have a week with no math. Okay, I'll try and slow down a little bit. I know, I apologize. Okay, what do you do first? Okay, good. So remember, class, that when you're factoring, you always have to have it set equal to 0. So Abby correctly started out by adding 24 to both sides. Okay? Yeah, you have to find two things that multiply together to be 24 and add to be negative 11. Eight and 3. So x minus 8 and x minus 3. Okay, so what are those two answers? Good. Okay, Calista, you want to talk to me about that? You get this, okay. I know. Yeah, no, I understand. My feet hurt right now because of standing up so much, talking, teaching. I do. I get exercise. Yeah, I should have one of those little things on there. Well, you should. What? They were using a graphing calculator, which you guys don't have those, so we're skipping. We both drive cars, yes. She does, yeah. She works in all the different schools, so she has to drive around a lot. Okay, Colby, how do I start out number 25? Take a cue. Yeah, sorry, Danica. I don't know why it got so hot in here all of a sudden. What did Abby do, Colby, to start number 24? Don't know. Okay, yeah, you got to set it equal to 0. So I'm going to add 4x to both sides, and I'm going to add 1 to both sides. Okay. Why wouldn't I just subtract the 4x squared? Great question. The reason why I don't want to do that is because we always, when we're factoring, want the first thing to be positive. Because if it's negative, then that just causes problems, okay? So I'm always going to bring those to whatever side that is, okay? All right, Colby, you got two things that multiply together to be 4x squared. 4 and 1 would work. But yeah, we're going to go with 2x and 2x in this, okay? And then you have two things that multiply together to be 1. 1 and 1. Okay, so this factors into 2x plus 1 times 2x plus 1, which, yes, you can write as 2x plus 1 squared if you want to. So what does x equal? Anyone? Negative 1/2. Because to solve that, you would subtract 1 and then divide by 2. And since that comes up twice, that has a multiplicity of 2. Okay? Okay. Couple more factoring ones. Gavin, did everybody go? Did everybody go? Yeah? Okay. So we're wrapped around again now. Okay. So Gavin, for 26, what do you do first? Okay, same thing that Colby did, same thing that Abby did. You get it set equal to 0. Okay? So I'm going to make this 3x cubed plus 3x squared minus 27x equals silence. Gavin, what do you factor out of those? What goes into 3, 3 and 27 evenly? 3. So I'm going to factor 3 out. And then since each one of the terms also has an x, I'm going to factor the x out. Okay? What am I left with when I factor 3x out of 3x cubed? Nice. What am I left with when I factor 3x out of 3x squared? No, sir. You're thinking about the very end. I need the middle, though, too. Good. All right. And then this one, it turns out, does not factor. There are not two numbers that multiply together to be negative 9 and add to be positive 1. So we don't leave it. Nice. Gavin nailed it. We're going to use the quadratic formula. So we know 3x equals 0. And we know x squared plus x minus 9 equals 0. Let's do this easy one first. If 3x equals 0, what does x equal? No, sir. 3 times negative 3 is not 0. We're not adding. We're multiplying. So it's 0. Okay. Josh, you said you never remember the quadratic formula? Well, good news. It's right in front of you. Okay. So a equals 1, b equals 1, c equals negative 9. So opposite of b, plus or minus the square root of b squared minus 4 times a times c, all divided by 2a. Yep. Yep. So here's what happened. Are you ready? Okay, let's go to the instant replay. Do you understand that a is 1, b is 1, and c is negative 9? Okay. So the formula up there, first thing it says is negative b. So since b is 1, that makes that negative 1. Okay. Plus or minus, because anytime you take a square root, you get a positive and a negative. Okay. Square root of b squared, what's 1 squared? 1 minus, always minus 4 is next. Ashland's stressing. Be polite. 4 times A times C. Okay? All divided by 2 times A, and since A is 1, 2 times 1 is 2. Okay? All right. Then 4 times 1 times 9 is 36. These two negatives make a positive. So 1 plus 36 is 37. Done. After that, I'm done. Yeah. Okay. All right. So we'll leave off right there, and then figure out the rest of it tomorrow.